Uh, and we are live. Who's going to be the first to join? Who'll be the first to join today? Hello, hello, welcome, welcome. Hello, hello. Afternoon, guys. I hope you're all well. Welcome, welcome. Let me know, guys. Can you hear me? Hello, hello. Welcome, welcome. Hello, hello, welcome, welcome. Hello, user. Hello, Fabian. Welcome, my friend. Hello, hello. Nice to be on the call. Welcome, welcome. Hello, hello. In this stream, guys, so in today's stream on Sunday, the 28th of April 2024, we're going to be doing the November 2022 AQA Paper 1 higher tier, okay? The first few questions will also be relevant for Ender Foundation. Hello, Brian Cox, welcome, welcome. Hello, Teddy, welcome. Hello, Jasmine, welcome, welcome. Nice to be on the call, Jasmine. Welcome back. Hello, hello, welcome, welcome. Right, let me know. Can you hear me, guys? Is everything crystal clear? Can you hear me? Yeah? Hello, Izzy, welcome, welcome. Hello, Mazima, welcome, my friend. Welcome, welcome. Okay, we're going to be attempting this paper, okay, and I'll try and do as many questions on this paper as I can, okay? Hello, V, welcome, welcome. Okay, those of you doing Edexcel, guys, it will still be relevant for you, okay? And we'll make a start in the next minute or so, okay? I'm just giving it a chance for people to join. Thank you, Izzy, for liking. Thank you, user, for liking. Hello, welcome, welcome, okay? I wonder, guys, can we get today's likes up today, okay? Can we try, if possible, and smash, let's say, let's be realistic here. So can we smash 15k likes? Okay, thank you, Lavinda, for liking. Thanks so much for liking. No, Aline, welcome, welcome. Thank you so much, Lavinda, for liking. Thank you, Izzy, for liking, you legend. Thank you so much for liking. Thank you, Izzy, for liking. Thank you, Lavinda, for liking. Guys, the likes are going up massively now. Wow. Hi, yes, Farhad, yes, this is higher, my friend. Thank you, Teddy, for liking. Hello, G. Thank you so much, Teddy, for liking. And thank you for the likes, as I appreciate all the likes, okay? Can you start? Yes, I'll start in just a minute or so, okay? I'm just giving a chance for people to join, okay? Thank you, Teddy, for liking. So anybody wondering where I got this paper from? I got it from um, Maths Genie or Maths Made Easy, okay, website, okay? If you want the copy of that. Thank you, yes, for following. Hello, Amy, welcome, welcome. Thank you, Teddy, for liking. Guys, the likes are flying through already. Only been here for a minute or so, okay? Right, guys, we shall make a start then, okay? So, the format today, guys, I'll give you a couple of minutes, okay, to try each of the questions. And then I'll go through it, okay, when I get a chance, okay? So, oh no, this is the one that I can't write on, can I? Oh, I can't write on it, sorry. Ignore me, guys, ignore me. Right, so, yes, we can start, okay, we can start, okay? Let me know, guys. Is this clear actually? Yeah, and can you also hear me, guys? Is the audio clear? Let me know. Thank you. Yeah, thank you so much for 1k likes, Radici. Thank you so much for 1k likes. Let me know, guys. Is the audio clear and can you see this clearly? Okay, I'll be right in here and see. Okay, cool, cool. Thank you, Ariane, for the share. Thank you so much for the share. Awesome, guys. We've got 15 people actually. This is a great start. Okay, this is a great start. Okay, so I'll give you a couple minutes to have a go at each question. Awesome, Dora. Awesome. Nice to have you on the call, Dora. Thank you for joining us here. Thank you for joining today. Thank you, Ayan, for sharing the live. Actually, I appreciate that. Thanks so much for sharing the live out. Awesome, awesome. Okay, thank you so much, Dora, for liking. Thank you for liking. Oh, sorry, let's just move down a bit. Why is this not actually working? Give me 1 second, guys. Sorry. Let me just make sure that no, it's not actually working. That part. Okay. So on the screen, we've got questions 1, 2, and 3. Okay. I'll give you 1 more minute. Okay, and then I'll share the answers, guys. Okay. Remember, this is a non-calculator paper. Okay. Hello, Michael. Welcome, welcome. Nice having the call. Thank you for joining me today, guys, and thank you for the support so far. Okay, Dora's put an answer for the first one. Okay, we shall check that in a second. Okay, well done, Dora, for putting an answer in. Okay, let me know, guys, are you ready for me to go through the answers or not? Sorry, pardon me. Right, guys, type in ready when you're ready, okay, and I'll share the answer. Thank you so much. Thank you, Dora, for liking. Okay, Teddy says ready. Anyone else ready? Okay, Harry's got an answer. Okay, let's double check it. Okay, question number 1, actually. Thank you, Harry, for liking. So work out -4 times -7/9. Circle your answer. Well, we know, okay, step 1, that a negative times a negative makes a positive, so it can't be option 1 and it can't be option 2. Now, when we multiply an integer by a fraction, okay, I can write it as -4/1. Okay, sorry about my handwriting, guys. Okay, so I write it as -4/1. Okay, and then I'm multiplying fractions. Okay, -4 times -7 is +28. Okay, and then 1 times 9 is 9. So the answer is 28 ninths. Okay, so well done if you got that, guys. Well done if you got that. Okay, so good start. Okay, sorry, guys, my keypad it's not the best today. Okay, so the answer is 28 ninths. Hello, Yasin. Welcome, my friend. Welcome back. Hello, hello. Hope you're well. Yeah, been a long time. Okay, so that's question 1 done. Okay, question number 2. Okay, drop ready when you're ready in the chat for me to go through. Circle the value of √6 to the power of 4. Okay, what is it going to be, guys? What is it going to be? Hello, Dylan. Welcome, my friend. Hello, Dylan. Welcome, welcome. Okay, Dylan's got an answer. Harry says ready. Okay, so let's go through it. Okay, so one way of doing it is that I know that √6 can be written as 6 to the power of a half. Okay, so √6 can be written as 6 to the power of a half. Okay, I've got 6 to the power of a half or to the power of 4. Now I've got the power to power law here. Now, what does that say? Well, a power to power law says, okay, that I multiply the powers, okay, if it's inside the bracket. So a half times 4 is 2. So I have 6 squared, okay, which is 6 times 6, which gives me the answer of 36. So I'm going to circle option number 2, which is 36, okay? Well done if you got that, guys. Okay, so well done, Harry. Well done, Dylan. Yep, spot on. Okay, awesome, guys. Awesome. Okay, next question. It says that 0.203 is equal to 1/5 plus x. Thank you so much, Dora, for liking. Thank you, Dora, for liking. Circle the value of x. Okay. So if it was me, I would change 1/5 into a decimal. So I'm going to write it as 0.203 is equal to 0.2 plus x. Okay, that's my first step there. Okay, because 1/5 as a decimal is 0.2. Again, if you're unsure about that, then please do obviously revise your fraction, decimal, and percentage, okay, conversions. Okay, hello, Elijah. Welcome, Elijah. Okay, Dora's got an answer. Okay, let's double check. Okay, I'm now going to subtract 0.2 on both sides. Okay, so keeping all of my place valuations. Sorry about my handwriting, guys. I apologize about my handwriting. It's not the best today. My keypad is a bit shaky on here. Okay, so I'm going to put a 0 there and a 0 there. So 3 take away 0 is going to be 3. 0 take away 0 is going to be 0. 2 take away 2 is going to be 0. And then decimal point lines up. 0 take away 0. Oh, thanks so much, Dylan, for the gift. Thank you so much, Dylan, for the rose. Thanks so much for the gift, and I appreciate that. Thanks so much for the gift. Okay, so 0.003. Now, as a fraction, that will be 3 thousandths, okay, because I'm looking at my place value. That's my units column, that's my tenths column, that's my hundredths column, and that's my thousandths column, okay? So it's 3 thousandths, okay? So it's 3 out of 1,000, okay? And that's the answer for question number 3, okay? So I'll give you just a few seconds to screenshot that, okay? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, moving on now. Okay, awesome, awesome. Okay, so next question. Okay, let's zoom in now. Okay, Elijah, I'll check it out. Yeah, if I get a chance. Yeah. I haven't got like a lot of actually like money in the minute yet, so I'm trying to obviously save up here to try and get like a new like writing pad. I've got one now, but it's just a bit obviously sticky. Okay, like to actually work with. Okay, thank you, actually. Thank you, Dylan. Actually, I appreciate that. Okay, thank you for the gift. Okay. So question number 4, it says circle the correct statement. Okay, those 3 lines just mean equivalency. Okay, so it's saying is the left hand side equivalent, i.e., the same as the right hand side? Actually, okay. So I'll give you a minute or so to have a go at that question. Hello, Sophie. Welcome, welcome, Sophie. Hello, hello. Oops, sorry. Why is it doing that? Okay, Dora's got an answer. Thank you, 0000 for sharing. Thank you so much, Mason, for sharing. Thank you, Dylan, for liking. Thank you so much, Dylan, for the rose. I appreciate the roses, my friend. That's very kind of you. Thanks so much for the rose. Thank you for the rose, my friend. That's very, very, very kind of you. I appreciate that. Thank you so much. Thank you for the roses, my friend. Thank you so much. I mean, I've set a target today, but it's quite ambitious. Yes, doing maths, TK, T1 tracks. Yes, doing maths. Okay, guys, so let's talk about it. Okay, so circle the correct statement. Okay, thank you so much, Dora, for liking. Okay, so is 3x equal to, i.e., the same as x plus 2x? Well, if I collect like terms, 1x plus 2x is 3x. So 3x is the same as 3x. So that is my correct answer. Thank you so much, Dylan, for the fire. Hey, thanks so much, Dylan, for the fire flame. Thanks so much for the fire flame heart. Thank you. Okay. So it's not this one, okay, because 3x is not the same as 2, okay, because that's what I call an equation. So it can't be that one. 3x plus x, okay, is 4x. 4x is not the same as 2 minus x, so it can't be that one. And finally, 3x plus x minus 2 is not equal to 0 or not equivalent to 0. So 4x minus 2 is not the same as 0, so it can't be that one, okay? So my answer is option number 1, okay? Does that make sense, guys? Okay, so that was a pretty, yeah, like a tricky question there, okay? Question number 5, okay? Drop ready when you're ready to do the answer. How? So those three lines there, okay, are what we call equivalency, okay? We're not solving an equation, okay? It's saying, is the left-hand side, this is actually higher, buddy. This is actually higher, sorry, yeah, it's higher tier, okay? Okay, Doris says ready, okay? So the left-hand side, okay, is not the same as the right-hand side, okay? So that's what it means, okay? Yeah, well done, Dylan, okay, spot on, okay? So does that make sense now? Okay, so next question. Okay, awesome, awesome. So divide 62 into the ratio 3:7. Again, this is a super hot topic. So it's sharing in a given ratio. So we're going to add our ratio parts. Oh my God, why is my pad today being so funny today? Sorry, guys, just give me 1 second just to try and set up a bit better. There we go. That's a bit better, I think. So 3 plus 7 is equal to 10. So we've got 10 pots in total. We now do the amount. Yep, spot on, Dylan. Yep, spot on. Okay, so 62 divided by 10. Okay, well done, Dylan. Yep, spot on, my friend. Okay, which is equal to 6.2. So 6.2 is equal to 1 pot. Okay, yep, well done, Dory. Yep, spot on, Dory. Yep, well done, Mano. 2. Yep, well done. Yep. So we want now want to work out how much 3 pots and how much 7 pots. Well done, Dinosaur. Yep, well done, Dylan. Yep, good work. Okay, oops. My pad is being funny today. I apologize, guys. So 6.2. Oh my God. Sorry, guys. I do apologize. Do you need the protractor for this question? No, you don't. Okay, so times it by 3. So 2 times 3 is 6. 3 times 6 is going to be 18. So we're going to have 18.6 there. Okay. And then lastly, we're going to have 6.2 times by 7. Okay. Sorry, guys, about my handwriting. I apologize about my handwriting. 14. So carry the 1. 76 is going to be 42 plus 1 is going to be 43. 43.4. And that, guys, is my final answer. Okay. Well done if you got that. Okay. Well done if you got that. Right. A few seconds to screenshot. Okay. 5, 4, 3, 2, and 1. This is GCSE level, my friend. So this is GCSE maths. Okay. Right, looking at some grouped data now. So looking at some group data, okay? So I'll try and zoom in a bit. Okay. Question number 6. Okay. So here is some information about the time spent on social media by 40 men and 40 women last week. Okay, so we've got some group data, okay? So tick one box for each statement, okay? The first one says 3 of the women spent more than 11 hours on social media, okay? Is that true, guys, or is that false? Yeah, I've got no idea like why people are just commenting, saying stuff now. What? Okay, so Doris says true, so let's double check. So number of women that spent more than 11 hours. So we're looking at these two parts. So 2 plus 1 is 3. Okay, 3 spent more than 11. Okay, so that is definitely true. Okay, okay, next one. The range for the men is 15 hours. Okay, is that true? Yes or no? Okay, Rihan's got an answer. Okay, let's double check. So the range of men. Well, there's none in this category. Okay, the highest for men could be 14, and the lowest it could be, for example, is let's say 2.01. Okay, so if we do 14 take away 2.01, okay, that's clearly going to be less than 15. Okay, so that cannot be true. Okay, well done, Rehan. Okay, yeah, well done, Dory. Yep, spot on. Okay, thank you, Nathan, for liking. Some of these comments are just being a bit silly today. Okay, right, next question. The women have a higher median than the men. Okay, is this true, guys? Yes or no? Well, to work out the median, guys, okay, we want to work out half of the total frequency. So step one is to work out half of the total frequency. So we're going to have 12. Oh, it says here actually, sorry, yeah, it says here actually, so it says 40 women and 40 men. So we got 40 women and 40 men. Okay, so step one, work out a half of 40. So a half of 40 is what, guys? So a half of 40 is what? Okay, well done, man. Yep, spot on. Okay, so we want the 20th value, okay, for the men and women, okay? So we start at 12. 12 plus 11 is 23. So the median for the women lie in this category here. What about the men? Well, 10 plus 17 is going to be 27. That's bigger than the median here. So also the median for the men lies in the same category, okay, as that. Okay, now, because they may lie in the same mean, okay, this might be true, okay, because for example, the median for the men could be 7.8, and the median for the women could be 6, let's say. Okay, thank you, Rihanna, for the follow. Thank you, Rihanna, for the follow. Thank you so much, Rihanna, for the follow. So, does that make sense, guys? Okay, so yes, the median lies in the same grouped interval. Okay, we don't know the exact data. Okay, so this may be true. Okay, thank you so much, Dora, for liking. Thank you, Dora, for liking. Hello, Otty. Welcome, welcome. Thank you, Dora, for liking. Okay, can I move on, guys? Can I move on? Thank you, Mana, for the follow. I appreciate it. I appreciate it. Thank you for all the gifts so far. Thank you so much for all the gifts. I appreciate it. Thank you. Okay, awesome. Thank you, Dylan, for liking. Thank you, Dylan, for liking. Thank you, Dora, for liking. Okay, next question. Looking at some column vectors, okay? So question number 7. The diagram shows the vectors A and B. As a column vector, A is 3, 2. What is the column vector for B? And it's worth 2 marks, okay? So remember, column vectors are your X component and then your Y component, okay? So it tells you how far left or right you go and then how far up and down you go, okay? If X is positive, then it's to the right. Well done, Dylan. Okay, well done, Dylan. Rihan, this is a higher paper, Rihan. Sorry, this is a higher paper. Okay. Okay, so Dylan's got an answer. Nathan's got an answer. Okay, let's double check. Okay, we go across four. Okay, so across four and then down one. Okay, so it'll be 4 - 1. Okay, so well done actually if you got that. Actually, well done if you got that. Okay, 1 mark for each correct number. Okay, next part. So the vector A. Thank you so much, Eric, for the follow. Thank you, Eric, for the follow. 3, 2. So to work out the column vector for 4A, I'm going to expand this vector bracket out. Okay, so I'm multiplying everything by 4. Okay, no worries, Rihanna, no worries. Okay, so what would my answer be, guys? Let me know in the chat. What would my answer be? Hello, Nick. Welcome, my friend. Hello, Katie. Welcome back. Hello, hello. Hello. Is it Sai? Sai, come on, welcome, my friend. Hello, hello. Nice having the call. Okay, Dora's got an answer, so let's double check. Hello, my friend. Hello, hello. Hope you're well. So we do 4 times 2, which is 12, and then 4 times 2, which is 8. So my final answer is 12, 8. Okay, and that's my answer for this column vector. Okay, awesome, awesome. Okay, no worries here. No worries, no worries. Okay, so next part C, is a vector A plus vector C is equal to the vector 3, 0. Work out C as a column vector. Right, circle your answer. So vector A is 3, 2. Okay, let's call vector C. So let's call it C1 and C2. Okay, that has to equal the vector 3, 0. So what would my answer be? Okay, so Katie's got an answer. What then, Katie? Yep. So, so let's double check Katie's answer. Thank you guys. Yeah, thank you for all the likes, as I appreciate all the likes, and thank you for the follows. Make sure you follow me, guys. Yeah, okay. Because I'm gonna try and do some regular lives if I can. Okay, Dora's got an answer, so let's double check here. So let's double check. So adding my x components, so 3 plus something equals 3. So C1 has to equal 0. Okay, so C1 equals 0. And then secondly, 2 plus something equals 0. Well, 2 plus minus 2 is 0. So C2 has to equal to -2. So my final answer is 0 minus 2. Option number 4. Okay, well done if you got that, guys. Yeah, well done. Okay, so well done, Katie. Well done, Dora. Okay, awesome, awesome. Okay, does that make sense, guys? Does that make sense? Okay, so a few seconds to screenshot. Okay, so 5, 4, 3, 2, and 1. Okay, so moving on now. Okay, so thank you, guys. Yeah, thank you for your support so far. Okay, right, looking at some fraction work. Okay, so looking at some fraction work. Okay, again, another common type of question. Okay, particularly on your non-calculator. Okay, so revise. Yeah, multiplication, addition, subtraction, and division. Okay, especially as well with mixed numbers. Okay, because edX or higher love to throw in here a fraction question at the start of an exam. Okay, so revise your rules of fractions. Okay. Also, guys, let me know. Yeah, are there any questions so far? Are there any questions, or is it making sense? So BidMass, yep. So Dylan, you are right. Yep. So we would use BidMass here. So we'd work out 7/10 minus 4/15 first, and then divide our answer by 2/3. Okay, well done, Dylan. Yep. Great start, Dylan. Okay, and thank you for interacting, Dylan. I appreciate your support. Thank you, my friend. Thank you. Thank you for liking, guys. Thanks so much for liking. Okay. Can we try and get to 20k in today's live? Okay, that is quite ambitious. Okay, but can we try and get to 20k likes? Okay, thank you, Dylan. I appreciate that. Okay, that is very kind of you. Okay, I tried to be positive here. I tried to be positive. Okay, but it can be tricky at times. Okay, but I'm trying my best here, obviously, support my students here and support you guys online. Okay, where I can. Okay, I'll give it like another minute or so. Okay, and then we'll talk about it. Hello, Bella. Welcome, Bella. Hello, Sebastian. Welcome, Evan. Thank you, Nick, for liking it. Thank you, Nick, for liking. Thank you for the support, guys. Hello, friend. Welcome. Okay, Dora's got an answer. Okay, awesome. Thank you, Katie. Yeah, thank you so much, Katie, for liking. Thank you, Dylan, for liking. Thank you, yeah. Thank you, guys, for liking. I appreciate it. Okay, guys, if you're not following, yeah, make sure you press that follow button, guys. Okay, if you can, yeah, please press that follow button, okay, because it means quite a lot to me. Thank you so much, yeah. Thank you, yeah. Thank you, Katie, for following. Thank you, M, for the follow. That's so kind of you. Thank you so much for the follow, guys. I appreciate it. Thank you so much. Thank you, Ria, for the follow. Thank you so much, Ria, for liking. Okay, guys, so let's talk about it. Okay, so work out, sorry, 7/10 minus 4/15 all divided by 2/3. Okay, so step one. So we're going to use BidMath. So work out the bit inside the bracket first. We got 7/10 subtract 4/15. Okay, so the key when it comes to subtracting fractions is we want to find a common denominator. Okay, so the lowest common multiple of 10 and 15 this year is going to be 30, okay? Because both numbers go into 30, okay? And again, yeah, if you're unsure, write out your times tables, okay, for 10 and 15, yeah, and find like the lowest common multiple, okay? But if you're ever in doubt, there is no harm in just multiplying the denominators, okay, and writing over 150, okay, and then simplify it at the end, okay, if you can, okay? Right, so times top and bottom by 3, so we get 21/30ths, okay, times top and bottom by 2, and we get 8/30ths, okay. Now I've got a common denominator, I'm just going to subtract the numerators, so 21 take 8 is going to be 13, so we get 13/30ths, okay. We're going to divide that by 2/3. Okay, those of you that have been following me here, it's that famous cliche acronym, okay, the KFC method. So keep the first fraction the same, flip the second, and then change it to a times. We have 13/30ths. Okay, then we're going to change to 3/2, and then we're going to multiply it, okay, for that, okay. So, well done, yep, so KFC, okay, spot on, okay. So keep, flip, change, or keep, change, flip, okay, KFC or KCF, okay. So these are little ways here to obviously remember in your exam, okay, in case you forget, okay. Whenever you're dividing fractions, remember the KFC method, okay. So keep the first fraction number the same, flip the second, okay, and then change to a times, okay. Thank you, M, for liking it. Thank you, M, for liking. Guys, almost 10k likes, guys. We are smashing it today. We are smashing it. Okay, so multiplying fractions, so multiply the top by top. So 13 times 3 is going to be 30. Sorry, 39, sorry, not 30. And then 30 times 2 is going to be 60. So we get 39/60ths. Okay, which if we simplify, divide top and bottom by 3. Okay, and we get 13/20ths. Is that right, guys? Or have I made a mistake? Sorry. Is that right? Okay, so Doria, I'm just double checking. I think that is right, yes. So 13/20ths is my answer. Okay, awesome. Okay, thank you, Nick. Here. Thank you for confirming. Okay, so my mind like goes actually a bit blank here sometimes. Okay, question number 9. Okay, work out all the integer values of x for which this double inequality is satisfied. Okay, so this is what I call a compound inequality. Okay, so we want to get it. Okay, so it's in the form x is less than something and greater than or equal to a number. Okay, so okay, awesome, Dora, awesome. Thank you so much. Yeah, thank you. Yeah, thank you, Katie, for liking. Thank you, Katie, for liking. Awesome. Okay, is it making sense, guys? Are there any questions so far? Let me know. Thank you, M, for liking it. Thank you, M. Thank you so much, Katie, for liking. I appreciate the likes, guys. Yeah, thank you for liking. Guys, we smashed it. 10K. Awesome. Okay, so Dora's got an answer. So let's give it a second. This is actually higher actually. So this is actually a higher tier. Okay, higher tier. Thank you. Thank you, user, actually, for responding, user. Thank you, user, for responding. Thank you. Thank you, guys, for liking it. Thank you, Nick, for liking. Thank you, Lucas Shush, for liking. I think that's right. Okay, so let's talk about it. Okay, so to go from 4x to x, we divide by 4. So we divide all three sides by 4. 12 divided by 4 is going to be 3. And then 25 divided by 4 becomes 25 quarters, which becomes 6 1/4, which as a decimal would be 6.25. Okay, so integer means a whole number. Okay, so integers means whole numbers. So the numbers that satisfy this inequality will be 3, 4, 5, and 6. Okay, yeah, and 6. Okay, so 7 would not satisfy this inequality. So in the chat, guys, can someone explain why would 7 not satisfy this inequality? So can someone in the chat let me know why would 7 not satisfy this inequality? Okay, can someone let me know? Yep, spot on. And yep, Warden M, yep, spot on. Okay, yep, Warden Dory, yep. Okay, because the number has to be less than 6.25, and obviously 6.25 is smaller than 7, so it does not satisfy that inequality. Yep, Samaya, yep, that is correct. Yes, so divide it by 4, okay? So not, yeah, round down, yes, yeah, round down, yeah, yes, round down, yes. Okay, so remember, yeah, read your inequality, guys, carefully, okay? Right, guys, a few seconds to screenshot that. Okay, 5. Do you have a voice change? No, it's not actually. No. It's a bit muffled. Guys, let me know. Can you hear me? Everyone thinks I've got like a voice change here, but I can barely like edit a video, guys. So I've got no idea how to she change my voice on here. I can hear you, but it sounds weird. Oh, okay. Guys, let me know. Can the rest of you hear me, guys? Okay, M says yes. Yes, we can hear you. Okay. Does it sound weird or does it sound normal? Awesome. Okay. Next question. Okay, everyone's favorite topic. Okay, looking at Venn diagram. Perhaps your mic. Yeah, I think it might be my mic. Yeah. I'll try and fix that for next time. Yeah, my mic, guys. Sorry, I actually apologize here for like not like the best mic. Okay, question number 10. Here is some information about 120 people who visit a shop. Just a bit muffly. Okay, sorry about that. I apologize, guys. I apologize about that. So, three-quarters of the people buy neither a coat nor a dress. 19 people buy a coat. 14 people buy a dress. Complete the Venn diagram to represent the information. Okay, so 19 people buy a coat. Okay, 14 people buy a dress. Okay, three-quarters of the people buy neither a coat or a dress. So let's work out three-quarters of 120, guys. So a fraction of an amount. So three-quarters of 120. Well done, Dory, yep, spot on. Okay, divide by the bottom and then times by the top. 120 divided by 4 is going to be 30. And then 30 times 3 is going to be 90. Okay, so 90 goes outside the circle but inside the box. So 90 goes there. Okay, right, the next part. Well, it says that 19 people buy a coat. So 19 goes there. Okay, for now. Okay, and then 14 people buy a dress. Okay, now this is where we can get a common mistake, guys. Okay, so the remainder, okay, will be 120 take away 90. Okay, so 120 take away 90 is going to be 30. But I've got a slight issue here, and the issue here is, okay, what does 19 plus 14 add up to? Anyone know? Hello, TikTok friend. Hello, hello. Okay, well done, Davika. Yep, spot on, Davika. Okay, so 19 plus 14 makes 33, okay, but we want to have 30. So we know that these numbers are not quite in the correct place, okay? So to even miss out, okay, I have to subtract, okay, 3 from each side. So 19 take away 3 will be 16. Okay, well done, Dory. Yep, well done, Dory. Yep. Okay, 14 take away 3 will be 11. Okay, if I now add this, I get 27. So the overlap must be 3 to make that 30. Okay, does that make sense, guys? Does that make sense? Let me know. Does that make sense, guys? Okay, awesome. Dora says yes. Are there any questions? Why wouldn't you take 3 from 90? Well, because so we want to find out, okay, the remaining for the two circles. Okay, so we want to work out, yeah, the remainder, obviously, yeah, of these three numbers. Okay, if 90 buy neither, it means that 30 remaining have bought a coat and or a dress. Okay, so we split 30 into those three segments of my circles. Okay, does that make sense now? Okay, awesome. Okay, awesome, awesome. Okay. So we don't take it off 90 yet because 90 were the ones that didn't buy any, okay? So the ones that bought something were the remainder 30 out of the 120, okay? Thank you, Nick, for liking it. Thank you, Dora, for liking. Hello, Lucy. Welcome, welcome. Thank you so much, Dora, for liking it. Guys, almost 12k likes. Awesome, awesome. Okay. Right, let's move on. Okay. So next question. Okay, hopefully it's a bit more clearer now. Okay, so looking at some simplifying powers. Okay, so laws of indices within a ratio question. Okay, again, another big topic, guys. Okay, so revise your laws and your rules of indices and also surds for the higher tier. Hello, Abdul. Welcome, welcome, Abdul. Hello, hello. Okay, so write 3 to the power of 6 times 3 to the power of 5 as a ratio to 3 to the power of 7 in the form n to 1, where n is an integer. Okay, so where n is a whole number. Okay, so I'll give you a few seconds to have a go at that question and then drop your answers. Okay, or drop ready when you're ready to talk about it. Okay, hello, Kevin. Welcome, my friend. Welcome, welcome. Thank you so much. Yeah, thank you, Kabian, for liking. Hello, David. Welcome, my friend. This is awesome, guys. This is awesome. Yeah, we've got 25 people here in the chat. This is awesome. Okay, so Dora's got an answer, so we'll double check. Dora, thank you so much. Yeah, thank you, Nick, for liking. Anyone else got an answer, guys? Let me know. And also, please do stop me, guys, if I'm going a bit too fast. Okay, please do stop me if I'm going too fast. Hello, Georgia. Welcome, welcome. Hello, Mitchell. Welcome, guys. I hope you're well. Hello, Dwayne. Hello, Ashvin. Welcome, welcome. Thank you, Amos, for liking. Okay, so we got an answer, guys. Okay, so sorry about that. So drop ready in the chat when you're ready, and I'll talk about it. Okay. Hello, Lisa. By the way, welcome, welcome, Lisa. It's nice having the call. Okay, guys. So let's talk about it. Okay. So write 3 to the power of 6 times 3 to the power of 5. The ratio of 3 to the power of 7 in the form n to 1, where n is an integer. Okay, George has got an answer, so let's double check. Okay, so step one, when you multiply with the same base, you add the powers. So 6 plus 5 makes 11. So we have 3 to the power of 11 to 3 to the power of 7. Okay, and we want that in the ratio n to 1. Now, to go from here to here, guys, yeah, okay, you divide a number by itself to get an answer of 1. Okay, so I'm going to divide both sides by 3 to the power of 7. Okay. So what we're going to have, guys, well, 3 to the power of 11 divided by 3 to the power of 7. Okay. We subtract the powers. 11 takes 7 is going to be 4. So we have 3 to the power of 4. Now, what is 3 to the power of 4? Well, it means 3 times 3 times 3 times 3. Well, 3 times 3 is 9. Okay, times 3 again, it will be 27, and then times 3 again, it makes 81. So our answer is 81 to 1. Okay, well done if you got that. Okay, well done if you got that. Okay, so our answer is 81 to 1. Okay, well done, Bridge. Well done, well done. Okay, well done, Albion. Okay, well done, Doria. Good work. Okay, does that make sense, guys? Hello, Lisa. Welcome up. Welcome, Lisa. Welcome back. Hello, hello. Why is it not 4 to 1? So we're not looking at the powers here, okay? We're looking for the actual number, okay? So 3 to the power of 4, isn't 3 divided by 3 1 though? So which bit are you unsure about? Sorry, which bit are you unsure about? Thank you so much. Yeah, thank you, Dora, for liking. Hello, Eri. Welcome, welcome. This ratio, okay? So to go from 3 to the power of 7 to 1, we divide it by itself, okay? Because any number divided by itself makes 1. So I'm dividing both sides of my ratio by 3 to the power of 7, okay? On the left-hand side, we have 3 to the power of 11 divided by 3 to the power of 7. We can subtract the powers if it's the same base, and we're dividing. We have 3 to the power of 4, which is 3 times 3 times 3 times 3, which makes it 81. Okay? Does that make sense, guys? Does that make sense? Okay, question 12 is now on the screen. Okay, awesome. Doris says yes. Take friend said yes. Okay, if I just put the power forward, I get the mark. Unfortunately, not. No, okay, because the question says where n is an integer, okay? So n has to be a whole number, okay? 3 to the power of 4 is part of the answer, but you have to write your answer as a whole number, okay? Hello, Jay. Welcome, welcome, Jay. So make sure yeah, that we answer the question, okay? Where n is an integer, okay? 3 to the power of 4, okay, it's just a power, okay? Yeah, obviously it's a number, okay, but obviously write it as a whole number, okay? No worries, no worries. Hello, Isaac. Welcome, welcome. Okay, question 12 is here. It's a bit more trickier. It says A is 10% more than B. Circle the ratio of A to B. Okay, I'll give you a minute here. Obviously, try this here, and then I'll talk about it. Thank you, Dora, for liking it. Guys, almost 15K likes here. We're smashing it today. And we're almost at 2.3K followers. That's awesome. Okay, Dora's got an answer. Anyone else got an answer? Let me know. Okay, Nick's got an answer. Hello, Thomas James. Welcome, welcome. Right, guys, let's talk about it. Okay, it says A is 10% more than B. Circle the ratio of A to B. So let's imagine, okay, yeah. So let's imagine that B is equal to 100%. Okay, so we'll say obviously B is equal to 100%. That means that A is equal to 10 more than 100%. So 10% more. So A would be 110%. So what is the ratio of A to B? Well, it'd be 110% to 100%. Okay, so 110%. Okay, 110 to 100. Okay, so simplify this ratio. So divide both sides by 10. We get 11 to 10. So we're going to circle option number 3. Okay, well done if you got that, guys. Yeah, well done if you got that. Okay, awesome, awesome. Okay. That was a bit of, yeah, of a trickier like ratio problem, okay? That's my answer for that, okay? Question 50, okay, a bit more nasty, okay? So we've got a reoccurring decimal and we've got adding a terminating, okay, to terminating decimal, okay? Okay, awesome, Emily, awesome, Emily. Thank you, Big Monk, here for sharing here. Thank you, Big Monk, for sharing. Guys, if you're new around there, make sure you press that follow button, okay, and check out the content on my page, okay? Thank you, Manamu, too, for sharing. Hello, Pops, welcome. Hello, Tavia, Mia Ahmed, welcome. Okay, Dora's got an answer. Anyone else got an answer, guys? Let me know. So the clue here is write it out as you would do using the column method. Okay, and obviously work it out. Okay, so let's talk about it, guys. Okay, because question 13. Work out 0.47 reoccurring plus 0.312. Circle your answer. So if it was me, I'd write it as 0.4777. Okay, dot. Okay, plus 0.213. Okay, so let's work it out. Okay, so we know that if we continue, we're gonna get 7 there. Okay, we'll get a 7 there. Okay, yeah, because see that 7 actually, it goes on obviously forever. Okay, so 7 plus 3. Is this right? Sorry, 4, 7. Sorry, I've copied it out wrong. Sorry, I've copied it out wrong. Thank you. Thank you, Dora. Thank you, Dora. Sorry, 312. Sorry about that. Okay, there we go. Okay, so 7 plus 2 is 9. Okay, 7 plus 1 is going to be 8. And then 4 plus 3 is going to be 7. Decimal point comes down, and then we've got a 0. So our answer is 0.789777777777, so on and so forth. So I can write that as 0.7897 reoccurring. So it's option number 3. Okay, well done if you got that, guys. Yeah, well done, Dorothy, and well done, Nick. Yeah, awesome. Okay, does that make sense, guys? Yeah, does that make sense? Hello, Casey. Welcome. Hello. Hello, Bobby. Welcome, my friend. Okay, so sorry about my handwriting, guys. Sorry about my handwriting. Okay, so a few seconds to screenshot. Okay, and then we'll move on. Hello, Marco. Welcome. Guys, any questions here, please do ask me, okay, if you're unsure about any bits, okay? Let's move on now. Okay, next question. So looking at some straight line graphs, okay, but in a context. So Craig wants to draw a graph for the values of x from -3 to 3, where the x coordinates and the y coordinates are in the ratio 2 to 1. Here is this graph, okay, or here is his graph, okay? Make 2 criticisms, okay, of this graph, okay? Hello, Todd, welcome. Hello, D. Hello, Lucky. Or Lakai, sorry. Welcome, my friend. Welcome. Okay. So, the first mistake, okay, or the first criticism is that it's meant to go from -3 to 3, it goes from 0 to 3, okay? So that is the first mistake here. So it goes from 0 to 3 rather than, okay, minus 3 to 3. Okay, well done, Doria, spot on, okay, rather than minus 3 to 3, okay. The second mistake here is a bit more trickier, is that it's saying that the x coordinate is double the y coordinate. Well, that's not true, is it? Because when x is 1, y is 2. So it should be, okay, it should be the ratio 1 to 2, okay, not 2 to 1, okay? Because to work out the gradient is the change in the y value divided by the change in the x value, okay? The gradient here, okay, so if you go across 1 and then up 2, okay, is 2 divided by 1, which is 2, okay? So the gradient here is equal to 2, whereas here, it's 1 divided by 2, okay? Here. So it's 2 and not a half, okay? Well done, Dora, okay? Spot on, okay? Does that make sense, guys? Does that make sense? Let me know. Is that clear? Okay, let me know, guys. Yeah, let me know. Okay, well done, Dora. Okay, spot on, Dora. Good work. Okay, thank you for answering it in the chat, okay, and thank you for your help in the chat. And thank you as well, Gian. Thank you, Nick, as well, for helping in the chat. Right, let's move on. Okay, so let's move on. Okay, right, so looking at some expanding double brackets here, and obviously single brackets. Okay, okay, so this is going to be slightly more trickier. Okay, but a nicer question. Okay. Thank you, Nick, for liking. Thanks so much, Nick, for liking. Guys, I'm so happy actually. We're like averaging like roughly like 10 to like 15 people actually for this live actually. So this is awesome, awesome, awesome. I'm very happy. I'm very happy. Okay. Make sure guys here they obviously follow me, okay, as I'll try and do more and more lives as we approach the exam. Okay, thank you, Dylan, for liking. Hello, Casper. Welcome, welcome. Right, guys, question number 50 next year. So let's talk about it. Okay. So show that 3x plus 4 times 2x minus 5, subtract 11x bracket x minus 2 plus 5 lots of x squared minus 3x minus 1 simplifies to an integer. Okay, so this is going to give us an integer. Okay, so step 1, expand each bracket out separately and being careful here with our negatives. Okay, so 3x times 2x is going to be 6x squared. 3x times minus 5 makes minus 15x. 4 times 2x makes positive 8x. And then 4 times minus 5 makes minus 20. Okay, that's the first part. The second bracket, minus 11x times x, so that'll be minus 11x squared. Okay, so Dora's got an answer here, so let's just double check Dora's answer. Okay, minus 11x times minus 2 makes positive 20. Sorry, let's just go back here, make sure that our live stays. Okay, sorry about that, guys. Sorry about that. Apologize. Okay, so plus 22x, okay, because a minus how the minus makes a positive, okay. Then we got plus 5x squared. Then we got minus 15x, okay, because 5 times minus 3x makes minus 15x. And then 5 times minus 1 makes minus 5, okay. Oops, sorry about that, guys. My handwriting here is actually awful actually today. I'm so sorry about my handwriting. Okay, right, collecting like terms. Okay, so let's actually change our color a bit. And let's make it a bit more thicker. Okay, so what do we have? Well, 6x squared plus 5x squared is 11x squared. Right, 11x squared issues. So they're going to cancel. Okay, minus 15x. Okay, minus 15x, yeah, makes minus 30x. Hello, Miss. Welcome, welcome. Hello, hello. Thank you, Miss. Yeah, thank you. Izzy, this is actually the November 2022 year higher tier, okay? So November 2022 year higher tier year paper on that year, non-calculated paper, okay? So November 2022 higher tier non-calculated okay, paper one exam, okay? Thank you so much, dear. Thank you, Miss M, for joining me. Okay, so that makes minus 30, okay? Plus 22 each year makes minus 8, plus 8 yeah goes to 0. Okay, so they all cancel. Okay, minus 20 minus 5 makes minus 25. And we've proved that our answer is just a integer. Okay, does that make sense, guys? Does that make sense? Hello, M4, JM4. Hello, hello. Thank you. Thank you, user, for helping me here. Thank you, user 1, 2, 3, 4, 5, 6. Thank you for helping me. Thank you, NJM4 for liking. Okay, right, let's move on. Right. Okay, slightly more tricky. It's a bit more of a harder question now. Okay, a graph has the equation y equals x squared plus px plus r, where p and r are constant. The graph passes through the points 0, 4, 1, 3, and 8v. Okay, work out the value of w. Okay, so let me give you a few minutes here to have a go at this question, and then we'll try our answer. Hello, hello, welcome, welcome, ting ting. Okay, hello, Jesse. Okay, so the first thing that I would do is I'd sub in 0, 4 into here to work out what r is. Okay, so my quadratic, okay, passes the y-axis at 0.4. Okay, because if I sub in x is 0, I have 4 equals 0 squared plus p times 0 plus r. Okay, so that simplifies to r is equal to 4. Okay, that's my first step here. Okay, does that make sense, guys? That is my first hint. Okay, so now our graph reads y equals x squared plus px plus 4. Okay, and I can substitute in my other coordinates. Okay, to work out um what p is. Okay, awesome, Dora, awesome, awesome. Okay, so I'll give you another minute or so to obviously work it out. Okay, well done, guys. Here, hello, Jesse. Welcome, welcome. Hello, Bougie, Boutique. Welcome, welcome. Hello, hello. Right, so I'm now going to substitute in the points 1, 3 to work out what p is. So x is 1 when y is 3. So we got 3 is equal to 1 squared plus p times 1, so that'll be p plus 4. Okay. So if we rearrange this, okay, so 1 squared is going to be 1. So 1 plus 4 makes 5. So 3 equals p plus 5. Hello, hello, welcome, welcome, hello. Subtract 5 on both sides. We get that p is equal to minus 2. So our quadratic now reads y equals x squared minus 2x plus 4. I'm now going to substitute. So, did you move the 4 to the left, to the right? For which part, sorry, which part did, so for this part here, 0 times 0 makes 0, p times 0 is 0, so okay, so it says second line. Um, so this part here just simplifies to 0, okay? So I get r is equal to 0, okay, when I simplify that, okay? Thank you, Alexia. This is actually AQAS, so it's AQH here, AQAH. Thank you, user Shim. Thank you, user for helping me here. Thank you, user for helping me, okay? So this part here, okay, 1 squared is 1, so 1 plus 4 makes the 5. Okay, subtract 5 on both sides, and I get p is minus 2. I'm now going to substitute in x is 8 and y is w to work out what w is. So we're going to have w is equal to 8 squared, okay, subtract 2 times 8, so subtract 16, and then plus 4, okay? Okay, so this just means, so yeah, this has come from 2 times minus 8, okay? So what would this be? Well, 8 squared here means 8 times 8, so that'll be 64. So 64, subtract 16, and then plus 4. Okay, yeah, so obviously take my time here. Okay, so 64 take away 16, that'll be 48. 48 plus 4 makes 52. So W, guys, is equal to 52. Okay, sorry, it should be a 2 there. Okay, apologies. So yeah, so 52, sorry. It isn't actually very clear. Sorry, it isn't very clear there. I should rub it out and write it again. So 52. Okay, there we go. Okay, does that make sense, guys? Does that make sense? Are there any questions? Okay, can I move on? Hello, Elise. Welcome, welcome. Okay, awesome, awesome. Okay, let's move on. Okay, we're getting there, guys. We're now over halfway. Okay, so looking at some commutative frequency. Okay, again, another big topic. Okay, especially on your exams. Okay, for higher and foundation. Okay, so what does it say? It says the table below. Sorry, the table shows information about the height of 60 athletes. Okay, so remember that. Okay, so 60 athletes. Sorry. Part A, complete the commutative frequency table. Okay, so we add up as we go along. Actually, so 0 plus 4 makes 4. 4 plus 4 obviously makes 16, and then 16 plus 35. Okay, that'll be 51 if I'm not mistaken. And then 51 plus 7 makes 58. and then 58 plus 2 makes 60. Okay. Hello, Fabian. Welcome, welcome, Fabian. Hello, hello. Hello, Love Hearts. Welcome, welcome. Okay. Does that make sense, guys? Sorry. Does that make sense for the first part? Are there any questions? Let me know. Hello, user. Welcome, welcome. Any questions, or can I move on? Hello, Y. WYSS. Welcome, my friend. Hello, hello. Hello, Rachel N. Welcome, welcome. Hello, Emily. Welcome, welcome. Hello, hello. Right, next part. What paper is this here? So this is actually the November 2022 paper one higher tier AQA. I missed it 1-to-1. Sorry, what does that mean? Thank you. Thank you, Yusuf. Help me here. Thank you, Yusuf. Help me in the chat. I missed it, TT. What does that mean, man? Sorry. Should I go over it again? Ah, okay. No, it's okay. I didn't think so. Ah, okay. No worries. No worries. Okay. Yep. No worries. Okay. Sorry about that. Okay. Okay. Did I did I answer your question earlier, Mana? Did I answer your question earlier about the fall? Sorry. Okay. 5, 4, 3, 2, 1. Let's move on. Right. Part B. Okay, sorry. This won't pop me for a while. Okay. It says circle the value or circle the class interval, okay, that contains the lower quartile. So the lower quartile is a quarter of my total data. Hello, Jasmine. Welcome, welcome, Jasmine. Hello, hello. So it's a quarter of 60. Okay, so a quarter of 60. So we do 60 divided by 4. So half it and then half it again. Half it and then half it again. So half 60 is 30 and then half it will be 15. So we want the 15th value. So if you look here, okay, 4 plus 12 makes 16, okay? So our lower quartile will lie somewhere in this region here, okay? Because we want the 15th value, okay? So it can't lie in my first interval. Yep, well done, Dory. Yep, spot on, Dory. Yep, spot on, okay? So it lies in the interval 160 less than h, which is less than or equal to 170, okay? And that's my answer for that question, okay? Hello, Lena. Welcome, welcome, Lena. Hello, hello. Hello, Omar. Welcome, welcome. Guys, is it making sense, guys? Is it making sense so far? Let me know in the chat. Is it making sense? Okay, awesome. Okay. Can I move on now? Okay. This was going to be a bit annoying. Yeah, to actually plot this graph actually, but I'll give it a go actually, but I probably can't actually plot it very well because obviously I'm doing it on a screen. Okay. But essentially, all we do is plot our endpoints with the numbers here, okay? So 150, yeah, so we start obviously at 0, 0, okay? So we start at 150 and 0, so I'll put a little dot there. Thank you. Thank you, Chris Hashem. Thank you. Yeah, thank you, actually, Kristen, for the follow. Hello. Hello, hello. Welcome, welcome. Okay, next one, okay, is going to be 160 and then 4. So 160 and then 4, so it'll be somewhere there. Okay, I'll try to zoom in to make it a bit clearer. Okay, 160 and 4, so it's going to be there. Okay, Okay, there we go. It's going to be 170, I think, yeah, and 16. Okay, there we go. Going to be there. Okay. Next one will be hello, hello. I think TV and also TV. Welcome, my friend. Hello, hello. Welcome, welcome. I hope you're well. Hello, hello. There's going to be 180 and then 51. Okay, so a bit of a jump there. 180 and then 51. Going to go there. Okay. And then there's 190, I think, yeah. And then it'll be 58, if I'm not mistaken. So it'll be somewhere there. Okay. Sorry about my lack of accuracy here. There'll be 260. Okay. With a pencil and a, okay, yes, it's accurate. Yeah. Oh, yeah. Thank you. Thank you. Okay. Oh, sorry. I'm probably going to actually butcher this here because it's not very good actually, but roughly looks like this. Okay. Probably not the best. Yeah, it's obviously a bit tricky because my keypad is actually quite wonky. Okay. But yeah, but you get the idea, guys. Okay, so it looks something like that. Okay, it's not actually perfect. Okay, but yeah, a rough sketch. Okay, obviously I'm doing on the screen. Actually, it's a bit more trickier. Okay. Hello, Sophia. Welcome, welcome. Okay. Thank you, Nick, for liking. Hello, Gcse revision. Welcome, welcome. Hope you're well. Right, 17D. So estimate the number of athletes whose height is more than 176. Okay. So we'll go to 176. Okay. Go up here. Okay. It's roughly 26. I want to say we do 60 minus 26. So 60 minus 26. Okay. Again, my drawing here is not obviously very accurate, but roughly. Okay. So 0 to 2 I can't do anything to borrow. 5, 10. 10 takes 6 makes 4. And then 5 take 2 makes 3. Okay. So it's roughly, okay, 34 people. Okay. Obviously, my accurate isn't very accurate there. Okay. I don't get it. Okay. Which bit, sorry? So which bit? Okay. So it says work out the number of athletes that is more than 176. Okay, so let's have a look. So 176 is about here. Let's draw like a little line. Okay, goes all the way up here. Okay, it's roughly okay 27 this year, so it's 27 on here. Okay, so we want the region where it's above that part there. Okay, this is awful. This is so difficult. This is why I hate these questions because they're so difficult to do on the screen. Sorry, guys. Okay, so we want the region that is above here. So we want this difference here, okay? For that and that, okay? Does that make sense, okay? So we want it when the height is greater than 176, okay? Okay, thank you. Hello, Zay, welcome, okay? Right, guys, can I move on now? Okay. Again, obviously, mine's obviously it's not obviously very accurate. Okay, but in the exam here, they will give you a bit of actually leeway. Okay. Yes, it would be yes. Okay, so it's the difference between 60 and that number. Okay, there. Okay. Yes, spot on. Okay. So always read the question carefully. Okay, and again, this is a super hot topic here for EdXL higher and foundation, aka higher foundation, and also OCR higher foundation. Okay. Right, let's move on. Okay. Let's have a look. Okay, so let's have a look. It's a bit more of a trickier. How many more questions do we have actually? So we've got 18. Got quite a few actually. Okay. So this one I'll probably actually skip actually because obviously it's a bit hard if you're doing the screen actually. So I'll skip, I think, 24. Okay, so we got about yeah, 8 questions to go, okay, roughly. So a road has three, yeah, so question 18 is here. So question 18. A road has three sections, D, E, and F. The lengths of D, E, and F are in the ratios D to E is 3 to 5, and E to F is 7 to 4. What fraction of the length of the road here is section D? So we've got D to E, okay. Hello, Jess, welcome, Jess. Hello, Snickers, welcome. We've got D to E, okay, has the ratio, okay, 3 to 5. We've got the ratio E to F. Hello, Ruben, welcome. Hello, my friend, welcome. So E to F is 7 to 4. Okay. So step one is to make it so the ratios for E's are both the same. Okay, how do I do that actually? Well, I'm going to work out the lowest common multiple, okay, of 7 and 5. Hello, Emma, welcome, Emma. Hello. So times this by 7, okay, so I'm going to have 21 to 35, and then times this by 5. So I have 35 to 20. Now I've got a ratio, okay, that is appropriate for D, E, and F, okay? So D to E to F is in the ratio 21 to 35 to 20. So 21 to 35 to 20. What fraction of the length of the ratio is section D? So that'd be 21 out of the total, okay? So 35 plus 20 makes 55, plus 21, okay, makes 76. Okay, and that is my final answer. Okay, well done, Dorothy. Well done, Robert. Yep, well done, Robert. Good job, okay? Does that make sense, guys? Are there any questions? Okay, awesome, okay. So let's move on now. Okay, question 19. Okay, yeah, so I'll try and be a bit quicker, yeah, because I'm just supposed to be conscious of time, okay? Okay, so question 19A. So we've got some negative indices. Okay, again, another big hot topic here, especially on the non-calculator exams. Okay, work out the value of 5 quarters to the power of -2. So the negative indice, it flips the fraction, so it makes it 4/5. And then I'm going to square my answer. So it's 4/5 all squared. So 4 times 4 makes 16, and then 5 times 5 makes 25. Okay, so my answer is 16/25. Okay, okay, well done, Dora. Yeah, well done, Dora. Okay, thank you. Yeah, thank you, Nick, for liking. Awesome, awesome. Hello, Kirsty. Welcome, welcome. Hello, Sophia. Welcome, welcome. Okay, next part. So write down the value of, or work out the value of 9/100 to the power of 3/2. Again, this is looking at a fractional index here. Again, yeah, it's another big topic here, especially on the non-calculator exams. Okay, what does this mean here? This fractional power. Well, I take the root, okay, of my fraction. So here, yeah, I'm gonna here take the square root, okay, of 9/100, and then I'm gonna raise that to the power of the numerator. Okay, so I'm gonna cube my answer. Okay, so the square root, yeah, of a fraction. So we square root, yeah, the top and the square root the bottom separately. So the square root of 9 is going to be 3. Square root of 100 makes 10. So we have 3/10. Now we're going to cube that. So when we cube a fraction, we cube the numerator and we cube the denominator. So 3 cubed is 3 times 3 times 3, which is going to be 27. And then 10 cubed is 10 times 10 times 10, which is 1,000. So we get 27 1,000ths. And that is my final answer, okay? Does that make sense, guys? Does that make sense? Okay, awesome. Okay, so remember, we do the root of the denominator of my fraction, and then we raise that to the power of the numerator. Okay, so here I'm going to have the second root, yeah, i.e., the square root, and then I'm going to cube my answer. Okay, if it was to the power, let's say, of 2/3, then I would obviously cube my number or fraction, and then obviously square my answer. Okay, yeah. So for example, yeah, if it's like 8 to the power of 2/3. You do the cube root of 8 and then square your answer, okay, for example, okay? You know, so again, another hot topic here for your non-calculator year exam, okay? Right, next question here. So question 20 and 21 on the screen, okay? So question 20. The only solution to this quadratic is x equals minus 15. Work out the values of b and c. Okay, so a quadratic normally has two distinct real roots, okay? Now here, I've actually got here what I call here a repeated here. So I've got what I call here a repeated root here. So if x equals minus 15 here is my solution, therefore x plus 15 is going to be a factor. So here, I'm doing x plus 15, okay? And then I'm going to square it, okay? Now, why is this, okay, equal to 0? Well, because if I solve this, okay, I get x equals minus 15, okay? Yep, spot on. Yep, well done, okay? Now, why am I squaring it? Well, because to go from a linear factor to a quadratic factor, I have to square the whole bracket, okay? So I'm going to have x plus 15 times x plus 15, okay? So does that make sense, guys? Does that make sense what I'm saying? No, okay, Mana says no. Okay, Doris says yes. Okay, Robert says yes. So, hello, thank you so much, sir, for the roses. Thanks so much, my Gcse Maths, you legend. Thank you so much. That's so kind of you. I appreciate it. Thank you so much, and thank you for being there, my friend. Thank you for being there. Okay, so just to go over it again, guys. So the solution to my quadratic, okay, is x equals minus 15 here, minus 15 here, okay? Now, generally speaking, a quadratic equation has two distinct real roots, okay? So when I solve a quadratic, I normally have two solutions. Now here, I'm only given one solution. So this is what I call, okay, a quadratic that has what I call here a repeated root, okay? So it has what I call here a repeated root, okay? So what that means is, okay, is that the linear factor, so x plus 15x here, I have to actually square that, okay, for me to get a quadratic in the form x squared plus bx plus c. Okay, hello, Ems, welcome, welcome. Okay, so does that make sense now, guys? Does that make sense now? Let me know. Hello, Ems, welcome, welcome. Because for me to get it in this form here, I have to square this linear factor, okay? So if I now expand it, so x times x makes x squared, x times 15x here makes 15x. Okay, so 15 times x makes 15x. Okay, so we've got 15x here obviously again. Okay, hello Gia, welcome, welcome, hello, hello. Okay, hello, yeah, long time, yeah, long time, I know, I know. And then 15 times 15x here makes 225. Okay, so now collecting our like terms, okay, what do we get? Well, we get x squared plus 30x plus 225. So b is equal to 30 and c is equal to 225. Yes, I am doing a past paper. Yes, okay. Yes, I'm doing an AQA higher tier past paper. Okay. Thank you so much. Yeah. Thank you, David. Yeah. Thank you for sharing the love, actually, David. I appreciate you sharing love. Okay. So does that make sense, guys? Are there any questions? Sorry. Are there any questions? Okay, Manus says yes. Okay, awesome, awesome. Okay. Okay, Gia says yes. Okay, awesome, awesome. Okay. So next part is reoccurring decimals to fractions. Okay, again, another hot topic for your paper one exam. So convert 0.611111, okay, to a fraction. Okay, so we let r, okay, or x, okay, so we let r equal 0.6, oops. God, my handwriting is terrible today, guys. I'm so sorry about my handwriting today. I apologize. It is a non-calc years. It is a non-calculator. Hello, hello, welcome, welcome. Hello, Mr. President. Welcome, my friend. Hello, hello. Hope you're well. Okay, so we have R. So R is equal to 0.61111111, so on and so forth. Okay, so 10R equals 6.11111. Okay, so on and so forth. Do you think I'm well on track? Well on track when I have the exam? It's called my FYP. No worries, Lily. No worries, Lily. No worries. This Wednesday. Um, I'm not sure you mean this year. So this Wednesday, I'll do well on Wednesday. My advice here, I think there is actually still actually a bit of actually time here. Thank you, Rana, for liking. Yeah, there was obviously a bit of time here, obviously before Wednesday. Okay, so just obviously rip out as many past papers here is my advice there. Okay, is that all right? Okay, so to work out 100R, Okay, times everything by 10 again. So we have 61.1111. Okay, we can clearly see here that the 10R and the 100R have the same number after decimal point. So I can do 100R, take away 10R, so that'll be 90R. So 90R is equal to 61.11111111, so on and so forth. Subtract 6.11111111, so on and so forth. Okay, so that will give me 55. Okay, because they all cancel here. So that obviously cancels with that. That cancels with that. So they all cancel. So y r is equal to, so r is, guys, 1 second. Right, guys, I think we're back now. Okay, can you hear me? Yeah? Let me know. Can you hear me? Sorry. We are back now. Can you hear me? Yes, okay, thank you, yeah, thank you, Dora, for liking. Thank you, Anna, for liking. Thank you, T1 Tracks, for liking. Okay, awesome, awesome. Okay, so last part now is to simplify this. Okay, although it didn't actually say it's simplify it, but that's fine. Okay, so simplify, divide top and bottom by 5, we get 11/18. And that, guys, is my final answer. So either fraction would suffice. Okay, awesome, awesome. Right, next part. Okay, we're gonna miss question 24, guys. Yeah, so we'll do 23, 24. Okay, we'll miss that because obviously it's a bit hard to do on a screen. We'll do this one, and then we'll do that one. Okay, and then we'll finish for today. Okay, so I think only about 4 more questions to go. Okay, so question 22. Okay, so looking at a tangent to a circle. Okay, again, another hot topic. Okay, this can appear on your non-calculator or your calculator. So yeah, either paper. Okay. So 4/8. No worries. Yeah, no worries, Dora. No worries. Thank you for being here, Dora. I appreciate your support here. Thank you for being here. Okay. So 4/8 is a point on the circle center O. The tangent 4/8 intersects the x-axis of point P. Work out the x-coordinate of P. Again, it's a 5-mark question. Okay. So step 1, work out the gradient from the origin to that point P. Sorry, not point P. Sorry, the point 4/8. Okay. So work out the radius here. So work out the gradient of the radius. So we got the coordinates 0, 0, and then 4/8. Okay. Gosh, my handwriting is appalling. I'm so sorry. So I'll try and obviously fix this for next time. I do apologize. So to work out the gradients here, so it's the change in y over the change in x. Okay. So we do 8 minus 0 is going to be 8, and then divided by 4 minus 0, which makes 4. So we get 8/4, which is equal to 2. So the gradient of my radius line, okay, of this line here is equal to 2. So this tangent line is going to be the negative reciprocal, okay, because it meets the radius here at 90 degrees. So it'll be minus a half x, minus a half, okay, because it is the negative reciprocal of 2, okay, because 2 times minus half here makes minus 1. So the equation of the tangent is y is equal to minus a half x plus c. Okay, I'm now going to substitute in the coordinates 4/8, okay, to work out the value of c. So when y is 8, the x coordinate is equal to 4. You have negative half times 4 plus c. And then if we rearrange this, well, that gives me minus 2. So we're going to add 2 to both sides. So we get that c is equal to 10. So we get y is equal to minus a half x plus 10. Okay, we want to work out point P where it crosses the x-axis. So the x-axis is when y is equal to 0. So we set y is equal to 0 here and solve for the equation. So we have 0 is equal to minus a half x plus 10. Okay. So step 1 here, if it was me, okay, add a half x to both sides. So we get a half x equals 10. So multiplying both sides of my equation by 2, we get that x is equal to 20. So point P has the coordinates 20, 0. Okay, so point P has the coordinate 20, 0. Okay, because remember, when a point lies on the x-axis, the y value or the y coordinate is equal to 0. Okay, remember the x-axis is the line y equals 0, and the y-axis is the line x equals 0. Okay, so thank you. Thank you, Cristiano Ronaldo. Actually, follow me. Okay, thanks so much for following me. Okay, does that make sense, guys? Are there any questions, or can I move on? Well, we've gained like 10 followers today. That is awesome. That is so good to see. Okay, and we're about to smash 20k likes. Today's a good day, guys. Today's a good day. Okay, are there any questions? Where did he get the 10 from? So the 10 came from, okay, so I substituted in the coordinates 4, 8 to work out the value of C, okay, in my equation y equals mx plus c, okay? So I subbed in x equals 4 and y equals 8 into y equals minus a half x plus c, and then I rearranged it to make c the subject, okay? Because minus a half times 4 is minus 2, which we have 8 equals minus 2 plus c, add 2 to both sides, and we get c is equal to 10. This is a non-calculated, yes, so it's a non-calculated paper, okay? Samaya, it is a non-calculated, yes, non-calculated, yeah, okay? Does that make sense, guys? Can I move on? Thank you, yeah, thank you for 20k likes, yeah. This is the highest number of likes this year. Yeah, I'm so happy today. This is a good day. Okay. This is actually higher tier, sorry, yeah, it is higher tier. Okay, let's move on. Okay, everybody's favorite, yeah, everyone's favorite. Exact trig values. Okay, yeah, thank you. Okay, so I'm going to be switching between higher and foundation year. Okay, but I'm going to set a live post here at some point tomorrow or Tuesday. Okay, for when I'll do foundation year and when I'll do higher. Okay, I want to try and focus a bit more on higher, as I've done quite a lot of like foundation tier papers already. Okay, but we'll mix it between the two. Hello, Molly. Welcome, welcome. Hello, E. Okay, question 23, guys. Okay, so 4 times sine 30 times tan 30 times cos 30 is equal to sine y. Work out one possible value of y. You must show your workings. Okay, so this topic here is knowing your exact trig values. Okay, if you're not sure, my GCSE maths year has a fantastic video on how to memorize the exact trig values this year. So if you go on his page, okay, thank you so much, yeah. Thank you, Sina, yeah. Thank you, Sina, for the follow. I appreciate it. Thanks so much for the follow. Okay, awesome, okay, awesome, okay. So check out, okay, or check out today's video on Corbett Maths here on YouTube, okay, for how to memorize the exact trig values, okay? So 4 times sine 30 years. So sine 30 years. So sine 30 is equal to a half. Okay. Cos 30. Okay. If I'm not actually mistaken here. So cos 30 is equal to root 3 over 2. And then tan 30 is a bit more tricky here. So tan 30 is actually 1 over root 3 or root 3 over 3 over 3, yeah? So tan 30 is 1 over root 3. Or if you rationalize it, it's root 3 over 3, okay? Okay. So next part. So we're going to have 4. So we're going to have 4 times a half times 1 over tan 30, sorry, 1 over root 3, sorry, times by root 3 over 2. Okay, and hopefully you can see shortly that things are going to start cancelling. So I'm left with a whole number. Okay, hopefully. Okay, so let's write it as 4 over 1. Okay, multiplying fractions. Okay, so we do 4 times 1, which is 4, times 1 again, which is going to be 4, times root 3, which is, so I'm going to have 4 root 3 on the top. And then on the bottom, what am I going to have? Well, 1 times 2 is 2. 2 times root 3 makes 2 root 3. And then 2 root 3 times 2 makes 4 root 3. Okay, so we have 4 root 3 over 4 root 3. Okay, anything actually divided by itself here is equal to 1. Okay, so we have that 1 is equal to sine y. Okay, now at this stage here, it is knowing about your trig graphs. Okay, so sine of what is equal to 1? Well, I know that sine 90 is equal to 1. So one possible value of y will be that y is equal to 90. Okay, so y is equal to 90. Okay, that's one possible value of y. Okay, so it's knowing your sine graph. Okay, yeah, well done, Zane. Well done, Zane. Okay, hello, Loretta. Welcome, welcome. Okay, so this topic is testing your exact trig values knowledge. Okay, and it's also knowing how to sketch it and what your sine curve looks like. Okay, no worries, no worries. Okay, so when I sketch, when I sketch a sine graph, okay, it looks something like this. Okay, yes, see a bit of a difficult one actually that she sketched. Okay, okay, oops. Can I go through the frequency graphs? Yes, I can do at some point. Yes, probably not today though. Okay. Oh my god, this is awful, isn't it? This is why I hate actually sketching again. I hate like sketches questions. Okay. So it goes from 0, it goes to 91, 180, 270 minus 1, and 360, okay? So a sine graph repeats every 360 degrees, okay? So the coordinates here are 91. So sine of 90 is equal to 1, okay? So at Gcse level this year, you're expected to know where the sine graph, okay, are at key points, okay? So it's 0, 91, 180, 270 minus 1, sorry, yeah, 270 here minus 1, and then 360, okay? And then it repeats every that, okay? Awesome, okay? So 560, yeah, so 560, so screenshot that, okay? 5, 4, 3, oh, thanks so much, sir. Thanks so much, sir, for the roses, sir. Thanks so much for the roses. I appreciate it. That's so kind of you, sir. Thanks so much for the roses. My target was actually 100 actually roses today, but we're actually quite a way off it today. Okay, we need 82 actually. We need 82 actually more roses here to obviously smash our target. But no panic, okay? No panic, okay? Thanks so much, sir. Thanks so much, okay? Right, let's move on. Okay, so let's move on, guys. Okay, so getting towards actually the end of the paper. Actually, yeah, this one here, I'll obviously skip it, and I'll come back to here in like another version. So I'll skip that. Yeah, we'll come back to that. Okay. Right, next part, okay, so we're solving a quadratic inequality, okay? So again, yeah, a grade 9 topic, okay? So I'll give you a minute to have a go, yeah, at the question, okay, or to think about it. And then I'll do the answer, okay, in the next 2 minutes, okay, in the next 2 minutes. Okay, type in ready in the chat when you're ready, and we can talk about it. Guys, thank you for all the follows today. Thanks so much for all the follows, okay? Thank you for all the gifts today, okay? Hello, Evie, welcome. Thank you for all the gifts. I appreciate all the gifts, guys. Thank you so much for all the gifts. Right, type in ready here if you're ready to do this question, and we can talk about it, okay, and give it a go. So 25a, it says solve the quadratic inequality x squared minus 5x minus 6 is less than 0. Okay, George said I don't get it. Okay, so let's make it clear in a second, George. Okay, so step one is to factorize, yes. So it is to factorize the quadratic, yes. So obviously factorize it, okay, so it's going to be a double bracket, okay. So step one is to factorize the quadratic, yeah, obviously inequality, okay. So x times x makes x minus, yeah, no worries, my friend, no worries, okay, no worries. It is again actually a bit obviously late last year. So x times x. Why is my pad so annoying today? This is so annoying. So here we go. X times x makes x squared. Then we want, yeah, what the matter, yeah. So two numbers here. So to make minus 5 here, so we want positive 1 and then negative 6, okay? Because 1 plus minus 6 makes minus 5, and then 1 times minus 6 makes minus 6, okay? So we want two numbers that add to make minus 5 and times to make minus 6, okay? So the factors of 6 are 1 and 6 and 2 and 3, okay? Well, thanks so much, here. Thanks so much, Never, for the rose here. Thanks so much for the rose. I appreciate it. Thanks so much for the rose. Thank you, Nev. Or Nevaya. I hope it's that right, actually. I hope it's that right. Okay. So, does that make sense, guys? So it's x plus 1 times x minus 6. Okay. Okay, awesome. Right. So, my solutions to the quadratic, okay? So, okay, will be minus 1 and then positive 6. Okay, so minus 1 and then positive 6. Okay, so yeah, it crosses at minus 1 and then it crosses at 6. Okay, so somewhere there. Okay, so it looks something like that. Okay, so that's what my quadratic, okay, looks like. Okay, are we happy with that so far? So minus 1 and then 6 there. Okay, so minus 1 there. Okay, 6. Okay, are we happy with that? Okay, so does that make sense, guys, so far? Does that make sense? So we want to know, okay, when is this quadratic below the x-axis? Okay, yes. So when is it below the x-axis? Well, it's below it, okay, in this region here. Okay, so it's below the x-axis, okay, for this region here, okay? So it's below it, okay, between -1 and +6, okay? Okay, so that's my solution to the quadratic inequality, okay? Does that make sense, guys? Okay, so when the quadratic, okay, inequality is less than 0, you want the region where it's below the x-axis or x-axis, okay? And when it's bigger than 0, okay, we want the region where it's above the x-axis, okay? So that's all it is this year. That is all it is this year. Does that make sense, guys? Emily, welcome, welcome. Does that make sense? Let me know, okay? Hello, Izzy, welcome, welcome. Hello, hello. I hope you're well today. Hope you're well. Yeah, can you just reverse numbers? Uh, what do you mean, George? Sorry, what do you mean by that? Sorry, let me know what you mean by that. Okay, so your solutions are x is -1 or x is +6. Okay, yeah, so your solutions here are always opposite to the sign there. Okay, this just means when is the graph below the x-axis? Okay, right, okay, right. Part B, show the solution x squared minus 5x minus 6 less than 0 on a number line. Okay, so it's going to be a hollow circle at -1, and then a hollow circle at 6, and then a straight line. Yes, yes, it is, George. Yes, yes, it is. So your solutions here are, oh my God, this is awful. My pad is terrible, Shim. So, Shim, my actual pad is terrible. Okay, okay, there we go. It's a bit better. Okay. But yes, okay. So you flip the signs to work out what your x-intercepts are of your quadratic key. So does that make sense? Let me know. Awesome. Okay. Right. Can I move on actually, guys? Yeah, can I move on actually? Okay. So we got two more questions, yeah, and then we'll finish for today. Okay. So sorry that I've gone on actually a bit longer than I thought. Okay. I apologize. Sorry about that. Okay. So looking at some circle theorems here. So circle theorem questions. Okay. So question 26, guys. Yeah. P, Q, and R are points on a circle. SP is a tangent to a circle. RQ equals PQ. Okay, thank you. Yeah, thank you, George, here for the follow. Thanks so much, George, for the follow. I appreciate that, Shia. Thanks so much, George, for the follow. Okay, so prove that y equals 90 minus x. Okay, so step one. So we can see actually, okay, yeah. So triangles PQR is an isosceles here, triangle here. Therefore, this angle and this angle here, so that all equal to y, okay? Because it is an isosceles, yes, it is an isosceles triangle, okay? And we also know one of our circle theorems that state that a tangent that meets the chord, okay? So this angle and this angle are what we call actually the same here. So this is what I call here the alternate segment theorem actually. So it's called the alternate segment theorem, okay? So when a line meets a chord, okay, this angle equals that angle there, okay? Does that make sense, guys? Okay, so it's called the alternate segment theorem, okay? So it's one of your theorems, okay, as part of your circle theorems at GCSE maths, okay? Does that make sense? Let me know, okay? Does it make sense? Awesome, awesome. Okay, yeah. So remember, yeah. So it's called the alternate. Sorry, yeah. So alternate segment theorem. Okay. So when a tangent meets a chord, okay, the the outside angle is equal to the corresponding angle. Okay. So this one and this one are equal, actually, George. Yeah. So this one and this one are equal. Okay. So this angle here is equal to 2x. Okay. So alternate segment theorem. Okay, so alternate segment theorem. Okay. So George, yeah, sorry, yeah. So it's this angle, okay, and this angle that are equal, okay, by the definition of the alternate segment theorem, okay. Right now, what can we do? Well, we know that angles in a triangle add to make 180. So we got y plus y plus 2x equals 180. Well, y plus y simplifies to 2y. So we got 2y plus 2x is equal to 180. Dividing the whole equation by 2, okay, we get that y plus x is equal to 90. And then if we then subtract x on both sides of our equation, we get that y is equal to 90 minus x, okay, as shown in the question, okay? That y is equal to 90 minus x, okay? And that is my answer to that circle theorems, okay, question, okay? Thank you, Ballard, for the follow. Thanks so much for the follow, okay? Hello, Ems, welcome, welcome. Hello, Ruth, welcome, welcome. Hello, 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 Daniel. Hello, Eddie Williams, welcome, my friend. Hello, Ruben. Hello, Cyber. Hello, Sina, welcome, welcome. Hello, hello. But yes, it will be, George. Yes, it will be. I can try Ems, yeah. If I get a chance, yeah, I'll try, okay? I'll try, yes. But the answer, George, it is actually yes, unfortunately, okay? Right, guys, last question, yeah, and then we'll finish for today. Okay, quite a nasty, yes, quite a nasty question here involving surds. Okay, so I'll give you a few minutes here to obviously have a go. Okay, and then I'll go through it here, and then we'll finish here. I know it's quite a nasty here. It's quite a nasty topic here. Surds here. It's quite a nasty topic. Okay, but again, another big topic here, especially on your non-calculator, okay, papers. Hello, Sam. Welcome, welcome. Okay, or shall I just go through it, guys? Shall I just do it? Hello, Phoebe. Welcome, welcome. Hello, SH7. Shall I do it, or shall I? Yeah, it's GCSE. Yeah, it's GCSE. Yeah, it's GCSE maths. Okay, George says yes. Okay, I'll do it then. Yes, it's high. Yep, it's higher. Okay, okay. So work out 2 and 3/16. Yeah. So square root. Yeah. Sorry. Work out. Sorry. Yeah. The square root of 2 and 3/16. Subtract 2/√5. Give your answer in the form of shear A with shear over B, where A and B are integers. Okay. Step one is shear. So let's obviously make this shear into an improper shear, improper fraction. Okay. We do 16 times 2, which should be 32. So 32 plus 13, yeah. So that obviously makes 45, so it makes 45. We get this, yeah, obviously 45 sixteenths. Subtract 2/√5, yeah, so 2/√5. Okay, so Does that make sense, guys? That first step there, okay? Does that make sense? So I've converted it into an improper fraction, okay? So 16 times 2 is 32. 32 plus 13 makes 45, okay? Right, our next step, okay? So to square root of fraction here, obviously I'm going to obviously square root here the numerator and obviously square root the denominator obviously separately, okay? Over root 16. And I'm subtracting 2 over root 5. Okay, so does that make sense so far, guys? Does that make sense? Thank you so much, yeah. Thank you, Anisha, for the follow. I appreciate the follow. Thanks so much, Anisha, for the follow. Okay, awesome, awesome. Okay, what is the square root here of 16, guys? Yes. So what is here the square root of 16 this year in the chat, please? Hello, Dylan. Welcome back, Dylan. So what is the square root of 16, guys? Hello, Kieran. Welcome, Kieran. Hello, hello. Hold on, George. Yep, spot on. Yep. M says 4K. Yep. So I can now rewrite this part as more than an each. Yep, spot on. More than another. Yep, good job. Okay. So we have root 5 yeah, over all over 4. Okay, subtract 2 over root 5. Okay. Now I'm going to simplify root 45 now. Okay. So root 5 yeah can be written as the square root of 9 times the square root of 5. Okay. So why have I chosen these two numbers? Yeah, yeah. So why have I chosen these two numbers? Okay, can someone obviously well done, Sinner? Okay, well done, Sinner. Yep. Okay, man. Yeah, I'll double check it. Well done, this. Yep. Because root 9 is here because obviously 9 is a square number. Okay. Whenever we simplify surds, guys, we are looking for the biggest square number factor that goes into obviously that number there. Okay. So root 9, yeah, obviously give me 3. So we're going to have 3 root 5 on the top, okay, of my fraction. Okay. So I can now replace this. Yep, well done, Mana. Yep, well done, spot on. Yep, well done, Anisha. Yep. Thank you, Anisha. Yeah, thank you, Anisha, for liking. Okay. So we now have 3 root 5 over 4. Okay, subtract 2 over root 5. Okay. So I'm now subtracting fractions. Okay. So I want to write it under a common denominator. Okay, so over 4 root 5 minus 4 root 5. So my final answer will be out of 4 root 5. Okay, okay. So now so let's obviously cross multiply. Okay, so I'm going to do that times that and that times that. So 4 times 2 is 8. Okay, 3 root 5 times root 5, yeah. So that'll be 3 times 5, yeah, which would be 15 inches. So we get 15 there. Okay, because root 5 times root 5, yeah, is root 25, which simplifies to 5. So we have 3 times 5, yeah, which is going to be 15. Okay, I can now subtract the numerators. So I'm going to get 7 on the top. Okay, the last part now is to rationalize this. So it's in this form. Okay, so I'm going to multiply top and bottom of this fraction by root 5. Okay, because I don't want a surd on the denominator of my fraction. Okay, does that make sense so far? Because I don't want a surd on the bottom of my fraction. Okay, so I'm going to rationalize it. Okay, okay, awesome. Okay, awesome. Okay, so what do I have here? So we have 7 times 5 is here. So we're going to have 7 root 5 here on the top. Okay, and on the bottom, guys, we're going to have 4 root 5 times root 5. Well, root 5 here times root 5 here is equal to 5. We have 4 times 5 here, which makes 20. So what I've put is 20, sorry, yeah, should be 7.5, sorry. Well, I've put 20, sorry about that. Okay. This topic here, so this topic here is looking at simplifying algebraic fractions, okay, involving surds, okay? So it's simplifying, yeah, algebraic fractions, yeah, involving surds, okay? So simplifying, okay, subtracting fractions with surds, and then obviously rationalize, okay? So my final answer is this, guys, okay? So well done, you've got that, actually. Well done, you've got that, okay? Okay. So well done, Manor, yep, well done, Manor, yep, spot on, okay? You were actually right, yep. And well done, is it your Suloja? Is it your Suloja? Sorry, yeah, well done to you as well, okay? Awesome, awesome. Hello, Simran, welcome, welcome, okay? Right, guys, that takes us to the end of today's paper, okay? So that is another past paper complete, okay, for the higher tier, okay? Are there any questions, guys? Okay? Are there any questions? Sorry for going on here a bit longer than I thought, actually. Sorry about that, okay? Are there any questions, guys? Okay, or are we happy to finish there for today? Okay, thank you for everyone here for obviously being here, okay? The papers here, so they're from actually, so yeah, so they're from Maths Genie, so it's from Maths Genie, so it's from Maths Genie, okay? So I'll put it on there, sorry. So I'll put on Maths Genie, okay? They're all on here, okay? There they are, okay? The foundation and then the higher, okay? All there, okay? Is that all right? Awesome, awesome, okay? Are there any questions, guys? Are there any questions, okay? Thank you, Shia. Thank you, Em, for obviously being here. Thank you, Mark, for being here. Thank you, Georgia, for obviously being here. Thank you, Jasmine, for being here. Thank you, Sinner, for being here. Thank you, Eddie, for being here. Okay, thank you, Amal, for being here. Thank you, Biggs. Thank you, Liam. Thank you, Radin. And thank you, Yosulucha, for being here. Okay, thanks so much. Yeah, I appreciate it. Okay, okay, so I will now say goodbye, guys. Yeah, are there any last minute questions, guys? Are there any last minute questions or not? No worries, guys. No worries, okay? No worries, Emashia, and no worries, Yoshimana. No worries, okay? Happy to help. If there's no questions yet, then I'll obviously say goodbye, yeah, okay? And thanks so much, yeah, for obviously joining today. And I shall see you all, okay, soon, okay? So how do I probably do on Instagram? Okay. Um, so you so you look at the region share, yeah, it's a bit more share, okay. So you look at the part of the chart that you want, and then you obviously divide it share by the like, yeah, divide it obviously by the actual top frequency, if that makes sense. So look look at the look at the area of one of your bars, okay, or the bar that you're looking at, and then divide it by the total frequency, okay? Does that make sense? So look at your selected part of the histogram, okay, and then divide that by the total frequency, okay? Right, guys, we'll obviously call it a day, okay, yeah. Hello, Ems, welcome, welcome. No worries, okay. Hello, Freya, welcome, welcome, okay. Right, guys, I'll now say goodbye to you, okay? So thanks so much, yeah, for obviously coming today, and I'll see you all very soon, okay? Bye for now. Take care, all the best. Bye for now.